Here's my lab two projectile motion of gravity versus gravity plus drag. Um, so for the purpose of this lab, we're observing real projection motion, extracting motion data using tracker, and then we are building a computational model using Newton's second law. We're going to be comparing experimental trajectory, gravity only model, and then gravity with the drag model. And then over here's just a photo showing Newton's second law, F equals ma. For the experimental setup, so our object was a loosely like wadded up paper ball with an estimate mass of 0.020 kilograms. And then we throw it like at a basketball angle. And then we have a fixed camera. I also have a ruler for calibration. Of course, this x-axis is the floor, like it's the meter stick, and then the origin is directly below the launch point. As you can see on the right, this is it from tracker, so zero is where it starts. Then we tracked all the way when it passes the line again. Our experimental data, initial position obviously 0, 0. So there's velocity from first two data I submitted based on tracker is Vx is 3.61 meters per second, and Vy being 7.73 meters per second. And then on the right, you can see just the angle. Yeah. So our physics model, like forces identified. So forces in this obviously gravity, drag force, the net force on it, which is obviously gravity and drag when we're using it. And also we need Newton's second law and then the momentum principle. For a computational model, so you set gravity like only, you set drag equal to nothing, and then with drag, obviously, we base off of whatever it is, obviously above zero. Um, and drag proportional to velocity squared, so the direct opposite motion. And then here you can see the glow script, and then I'll show the program quick. Okay, so right here I have it in another tab, but if we run this program, you see also the trajectory and all the graphs with it. And then yeah, so gravity only prediction, parabola, symmetrical path, obviously so it overshoots. That's just kind of the way we measured it. Um, Obviously gravity with drag prediction. We just have the same photo with it, but um, slightly shorter range, slightly lower peak height, better, like better agreement with the experiment. It adds more to the experiment. There's like the model comparison for tracker and then glow script. You can see that they're relatively similar. Obviously, they're a little off. I mean, there's air resistance with it, which we didn't obviously take into account too much. But yeah, I mean, honestly, looking at these two, I feel like you can see that it's fairly accurate to what we assumed it would be. But yeah, terminal velocity is one thing I take into account, which we took into account these, the peak height. And so did it show a gravity only? No, it wouldn't. But with the graph, with the drag, it did. Um, and then so for our what if scenario, so without drag, this is what y would equal to. And so the time of the ground would be longer because all the velocity would be vertical and it'd be a greater max height if we would throw it straight up with no X factor in it. And then with drag, it'd be even longer because the drag would stop on the way up and on the way down from moving. Analysis conclusion, so after this experiment, we also take into account there's several errors that could have occurred during this lab. So, calibration on the track, a little off. So obviously limits on the frame. That was a problem when doing it. It kept moving. It was hard to get it right. And obviously we're manually choosing those selection points of when to measure. Camera angle is, obviously supposed to be flat, but it's a human holding it. And then we're just assuming that the drag be a constant B. And then for our conclusion, Newton's second law, statically modeled, gravity dominates motion, and then drag slightly improves accuracy, and the Cauchy model matches pretty well. It's the real one. Thank you.